Hey, you guys. So today is our first official new lesson, basically, it leading into Unit 7. Unit 7 is all about what's called a confidence interval. So take a minute and just read this slide. I would recommend pausing the video. Just read through it, and then I'm going to talk about it once you are ready. All right, so the basic idea, you guys, of a confidence interval is just like what it's talking about on here. It's not practical to find the lifetime of every iPhone battery or all undergraduates about their attendance or to actually weigh every single burger that a particular restaurant's cooking, things like that. It's one of those things that we talk about in stats a lot and that we've talked about this year where it's time consuming, it's not cost effective, and so we couldn't possibly know this is the number for everything. So my question posed to you guys, think of one thing we would like to know the answer to, but couldn't possibly know for sure. So for example, I'm thinking about coronavirus and everything that's going on right now. We don't actually know how many people have this virus. We only know those people that have been tested positive or those people that have checked into a hospital. Like there's probably people in this country that either have the virus and they're not showing symptoms, or it's not serious enough to go to a hospital or anything like that, so they're just kind of hunkering down. And it's like, how would we be able to know for sure exactly how many people, if you keep those kind of ideas in mind, right? So Chapter 7 at the bottom, I like this paragraph, begins the formal study of statistical inference, using information from a sample to draw conclusions about a population parameter such as p or mu. This is an important transition from Chapter 6 or Unit 6, where you were given information about a population and were asked questions about the distribution of a sample statistic, so p hat or x bar. Now the idea is we're kind of going the other direction. What if we have a p hat? How can we use that to estimate what the true proportion of every single iPhone battery lifetime is, right? If we have that sort of thing. So this is the activity we would have done in class. And it's a good activity just because I wanted to kind of talk through it. So I was going to put you guys in teams, and then I stored a value of mu in my calculator. And so then what I was going to do is type in this value right here. And what that would do is that would actually give us a sample statistic. So I actually have already done that. I'm not going to tell you what the value of the true mean, is, right? That I'm keeping that secret. The only thing I am going to tell you is that when I typed this answer in, I got an X bar of 22.68 if I round. Okay, so basically what I would have asked you guys is, okay, if that was our X bar, what would you say is the range of values that we could possibly say the true mean is, right? So a lot of conversation started around that where it's like, okay, well, you could say anything from 0 to 100. Well, but that's kind of a wide range. That's not exactly what statistics is meant to do. It's supposed to help make predictions, right? So maybe some of you guys would be like, no, I'm going to guess between 20 and 25. Okay, well, what if my true mean was 19? You just left it out, right? So it's one of those like, how can we be as precise as possible while still estimate it? So this activity illustrates one of the most common tasks of a statistician, using a sample statistic to estimate the value of a parameter. When Mr. Gerard's class did the mystery mean activity, they obtained a sample mean of 23.8, and they estimated then that their interval plausible values 13.8 to 33.8. So I'm assuming his class said plus or minus 10 from that number. Okay, that's called an interval estimate or a confidence interval. The whole idea is if we take a sample statistic, an X bar or a P hat, how can we then take that and find an interval of, here's how confident I am that the true mean or the true proportion is between this number and this number. I kind of like this this comic right here. So taking a look at tomorrow's weather, the high temperature will be between 40 below zero and 200 above. And then Garfield just says, this guy's never wrong. That's the whole idea of confidence intervals. Like, okay, we could say, oh, the temperature will be between negative 40 and 200, no big deal. But that's not exactly how that works. When you look at the weather on the Weather Channel, they have a certain confidence interval they set to. And they have a ish, here's what we're looking at. There's been multiple times where you go outside and you're like, oh, it's way warmer than what the weather said, or vice versa. So interpreting a confidence interval is something we're going to talk about next, and that's called the confidence level. The most common confidence level is 95%. Those of you guys that are in AP Bio or have taken AP Bio, and you talk about like chi-squared and why are we using 5% and things like that, they kind of all go together. Let's see. So, the Gallup Polling Organization recently asked a random sample of U.S. adults about the most important financial problem facing their family today. There were many different options, with healthcare costs leading the way with 14% of responses. Based on this sample, the 95% confidence interval for the population proportion is 0.1 to 0.18. That is, and then this is where the interpretation comes in. Here's how you would word this. We are 95% confident that the interval from 0.1 to 0.18 captures the proportion of all US adults who would say healthcare costs are the biggest financial problem, right? You're using this one sample statistic to make an estimation for every single family in the entire country, right? You're not going to get a response from every single family in the entire country. So the idea is we take the data we have and make an estimation as best as we can. So one thing just to be careful, by the way, just when you're interpreting a confidence interval, make sure you're describing the parameter and not the statistic. Like, we are using the statistic to estimate that this is the parameter. We are using the X bar to estimate the true mean, or mu. We are using this p hat to estimate the true p, okay? So for example, here's a good problem. A large company is concerned that many of its employees are in poor physical condition, which can result in decreased productivity. To determine how many steps each employee takes per day, on average, the company provides a pedometer to 50 randomly selected employees to use for one 24-hour period. After collecting the data, the company's statistician reports a 95% confidence interval of 4,547 steps to 8,473. Interpret this confidence interval. Normally I would write this down for you guys, so just listen to the answer because my pen isn't exactly super accurate, so when I go to write long sentences, it doesn't turn out well. But so basically we would say we are 95% confident that the interval between 4,547 steps and 8,473 steps, we are 95% confident that the true mean number of steps per employee lies within that interval, is kind of how you would say something like that. So the other thing we're going to talk about too is you can also say, instead of between this number and this number, you can actually use a system kind of like this, where, for example, if you look down here, one of our intervals was between 0.1 and 0.18 when we were talking about the percentage of adults who say healthcare is the main financial problem, right, in their world. You can also actually find the middle of those two numbers and then use plus or minus blah, blah, blah. So it's almost kind of like finding the middle number and saying, I think our average is 0.14, plus or minus 0.04 either direction. Okay, so you can also do an interval that way. Basically what that's called, this guy right here, the 0.14, is the point estimate. Okay, and then the 0.04 is called the margin of error. Meaning if we had to make a best guess for the true value of P, we'd probably say 0.14. Like if we had to pick a number. But because of our confidence interval, right, we can't super confidently say, oh, it's just 0.14, but we can say, oh, it's 0.14 plus or minus 0.04 either direction is kind of the idea. So these two vocabulary words, you guys will see a lot moving forward. Okay, so this slide right here, if you want to pause and read through it, you can. It's not as essential. It's just the true definitions of both. Okay, the point estimate is like the single value estimate of that true population parameter. Like if I had to make a guess, here's what I got. And then based on our confidence interval, that's where we say plus or minus this many either way. So in the previous example, we learned that there are 95% confidence interval for the true mean number of steps taken per day for all, that's the key word there, right? All employees at the large company is this value. Calculate the point estimate and margin of error to create the confidence interval. So what you want to do is basically you want to find the number in the middle. So it's kind of like finding the mean, right? So off to the side in my calculator, I'm typing in the 4547 plus 8473 and dividing by 2. So if I had to pick a number for this is the mean, the actual true mean for all employees, how many steps they take, I would say 6,510 steps, okay? If I had to pick one number. But we know that that's not going to be super accurate, right? Like we haven't actually gathered the data from every single employee. It's not going to work. So then what I do is I take the larger number of the interval, so 8473, and subtract 6510, and I get 1,963. That's my margin of error. So plus or minus 1,963 steps. Okay, that is our 95% confidence interval. And like I said, confidence intervals, you can write them as between this number and this number, or you can write it as point estimate plus or minus margin of error. All right, so in the preceding examples, we learned right, it says all the same thing. So I'm going to start right here. Recent health guidelines suggest that people aim for 10,000 steps per day. Is there convincing evidence that the employees of this company are not meeting the guideline on average? Well, yeah. If the guidelines are you should be taking 10,000 steps per day, well, we're 95% confident that the actual mean number of steps they take is between these two values. And 10,000 is outside of that interval. So, yeah, I mean, it's possible we have a 5% chance we screwed up, but that's pretty low. So I would say there's convincing evidence the employees are not meeting that guideline, and that if that's something that is being asked of them by their boss, then maybe higher ups in the company need to have a conversation about, hey, how can we get you guys more active? Or I've heard of companies where they do like a health and fitness contest where you log in the amount of time you spend exercising, and then you set up teams and who's going to win and all that kind of stuff. So I definitely think this company needs to put some of those measures into place. All right, so here's an example question. I would like you guys to pause the video at this time and try it, and then when you are ready, unpause it and I'll give you the answers. All right, so number 1, interpret the confidence interval. This is exactly how I would write it too. So those of you guys taking AP next year, this is the sentence structure. We are 95% confident that the true proportion of all US adults that approved of Obama's job performance lies between 0.39 and 0.45. Okay, so we're using that interval to estimate the true proportion if we were able to get every single US adult to tell us, okay? Point estimate, I got to find the average. So 0.39 plus 0.45 divided by 2, and I get 0.42. So then 0.45 minus 0.42, so there's my point estimate, so then that must mean my margin of error is, so plus or minus 0.03, okay? Is it plausible that on the day of the 2014 midterm elections, a majority of US adults approved of President Obama's job performance? And explain. So when I hear a majority, I think 50% or higher, right? Well, here's the deal. We are 95% confident that that's our interval, that the true proportion of people who approved of Obama's job performance during those midterm elections is between that number. So really, it's plausible, right? Like it could have been that the majority approved of Obama's performance at that point in time, but it's very unlikely. Basically, there's a 5% chance that it was majority. And I've kind of started hinting with you guys about how 5% is the cutoff. If anything under 5%, it's so unlikely that it's like, not quite. So is it plausible that the majority approved? I would say yes, but on such a small scale that it is extremely unlikely. Okay. All right, you guys, there's no homework for today, but there most likely will be a homework assignment tomorrow. So check in to get the video for tomorrow. I hope everyone's well. If you got questions, stop by and see me for office hours.